All right, now we're going to look at how to calculate the standard deviation for a discrete random variable. So the formula is sigma equals the square root, and then we're going to take the sum, and we're going to take each x value minus the mean. We're going to square that, and then we're going to multiply that by the probability of the x value. And that whole thing is what's being summed. So we're going to go back to a previous example where Jason had his ice cream cart, and he was finding the probability of selling X number of vanilla cones in a day. We have the results in our table. Everything is the same number of cones sold, same probabilities. We had the mean in a previous video. That was 158.6 cones. I think it was 158.6. It might have been 0.9. Point 0.6. I was right. Okay. So we're going to use this to find the standard deviation. So the first thing I'm going to do is take each x value and subtract the mean and square that answer, and then I'll multiply them by their probabilities, add everything up, and then do the square root. We're going to do this one time by hand here in the notes so that you can see what's happening behind the scenes, and then after this, we will have technology to help us with these calculations. So let's see. I think I can set this up in a table. So if I take my x values and then the mean, and then x minus the mean, x minus the mean squared, and then x minus the mean squared times the probability. This looks like the best way for me to do this is in a table, and I wish I didn't have such a large data set, but that's okay. We will make it work. If you don't want to do a table, that's totally fine. Do what works best for you. All right, so 120, 130, 140, 150, 160. Rewrite that one a little bit lower. 170, 180, 190. I'm going to put some dividing lines in here to keep everything straight. And organized. Okay. And then our mean all the way down is 158.6. And then x minus mu. So 120 minus 158.6, negative 38.6, negative 28.6, negative 18.6, negative 8.6, 1.4, 11.6, 28.4, 21.4, and 31.4. Then take the previous column and square the number. Make sure you're putting the negatives in parentheses. .96, 8.6 negative squared, 73.96, 1.4 squared, 1.96, 11.4 squared, 129.96, 1.4 squared, 457.96, 31.4 squared, 985.96, and then multiply each of these x's by the probability. So 1489.96 times 0.071, 105.78716. I'm going to keep all the decimals right now. 58.07516, 345.96 times 0.143. This is really just tedious more than anything. Sometimes it's nice to just do some straight calculations. .96 times 0.071, 9.22716, 457.96 times 0.143, 65.48828, 985.96, 0.143. Last one, 140.99228. And then I'm going to take the sum of the last column. And I got 440.04. And then the last step is to take the square root of that, 440.04. And that gives us a standard deviation of 20.978. So Jason is selling an average of 158.6 vanilla cones with a standard deviation of 20.978 cones. That's quite a big spread. So if I were Jason, I would probably want to keep anywhere from 140 to 170, 180 cones on me in any given day, because that's a pretty big standard deviation to have. Might want to look into this and figure out why my standard deviation is so large. But as we can see, our range is from 120 to 190. So it makes sense that we would have a fairly large standard deviation. Okay, so even though we're calculating the mean and the standard deviation a little bit differently, the things that they tell us, the center of the data and the spread of the data, are the same. So that is how we calculate standard deviation of a discrete probability distribution by hand.